Assalamualaikum warahmatullahi taala wabarakatuh dan selamat sejahtera. Untuk hari ini kita akan memulakan chapter baru iaitu chapter 6 Data Description. Learning outcomes. At the end of this lesson, students should be able to identify the discrete and continuous data, to identify ungrouped and grouped data, and the third is to construct and interpret stem and leaf diagrams. Statistics is a science that deals with collecting, organizing, summarizing, presenting, and analyzing data. In the field of science, statistical techniques are used to analyze data that is created from the experiment. But in the field of education, statistical techniques are used to analyze the progress of the students in examination. Two types of the data. Quantitative data is the one which the resulting observation can be measured. Example, age, weight, height, and marks. For qualitative data, is the one for which numerical measurement is not possible. Example, colors and types of cars. Quantitative data divide by two. The first one is discrete data. The discrete data is a data that assumes countable values. For example, the number of students in a class, the number of cars sold on any day at a car dealership, and the number of a person in a family. For continuous data, is a data that assumes any numerical value over a certain interval. Example, the weight of student in a class, the time taken to complete an examination, and the income of a family. Example 1. A survey was carried out on 30 women and 50 men in Kedah to find out whether they support the action taken by the government to revoke the licenses of small petrol kiosks near the Thai border. State the population. The population is resident in Kedah. The sample, 30 women and 50 men. The variable, revoke the licenses, and the type of variable, qualitative or quantitative. So revoke the licenses is qualitative variable. Example 2. Categorize the following information into qualitative or quantitative data. The height of the boys is quantitative. The types of footwear is qualitative. The age of lecturers, quantitative. The colors of cars, qualitative. Make of motorcycles, qualitative. And the number of A's scored in public examination is quantitative. Example 3. Based on the following statements, determine either the data is discrete data or continuous data. The time taken to travel from Ipoh to Kuala Lumpur is continuous data. The number of pens sold by a stationery shop is discrete data. The diameter of the 10 spears is continuous data. The number of customers in a cinema in one day is discrete data, and the weight of newborn babies in a hospital is continuous data. Introduction of ungrouped and grouped data. Ungrouped data are listed as a sequence or in the form of a frequency table, but without the use of interval. This is an example of sequence. B. Example of a frequency table. Means here, we have 4 families that has no child. We have 6 families that have 1 child. We have 7 families that have 2 child, and so on. For group data, is grouped in interval, are categorized into mutually exclusive interval, can be presented in a frequency distribution table, histogram, polygon, and or GIF. Example, weight from 30 to 40 kg, we have 2 frequency. 40 to 50 kg, the frequency is 8. From 50 to 60 kg, the frequency is 6. And from 60 to 70 kg, the frequency is 5. Stem and leaf diagram for ungrouped data. A stem and leaf diagram will contain all of your data in all of its details. It is also as a stem plot. The shape of stem and leaf is the same as a histogram. Each value in the data is divided into 2 parts, the stem and the leaf. If all the data are 2-digit numbers, the first digit is the stem and the second digit is the leaf. For example, 58 can be divided as a 5, 8, where 5 we call as a stem and 8 we call as a leaf. Example 4. The length of 16 leaves of a certain tree correct to the nearest 0.1 cm are given below. Construct a stem and leaf diagram to represent these figures. First, we write stem, and right side we write as a leaf. For the value 4.4, we write 4 as a stem, 4 as a leaf. For second value 5.9, so 5 as a stem and 9 as a leaf. For 6.0, 6 as a stem, 0 as a leaf. We already have stem of 5, so for the value of 5.7, we just write 7 as a leaf. For 6.2, we just write 2 as a leaf. For 5.3, here is 3. For 8.0, we write stem as a 8, then 0 as a leaf. For 5.0, just write 0 as a leaf. For 6.3, we write 3 as a leaf. 5.7, 6.6, 5.5, 4.3, 5.9, 4.8, and the last one is 8.1. Now, we rewrite stem and leaf in ascending order. So we have 4. We arrange 4, 3, 8 as a 3, 4, 8. For stem of 5, we rearrange the number as a ascending order. So 0, 3, 5, 7, 7, 9. 9. For stem of 6, we have 0, 2, 3, 6. And the stem of 8, we have 8, 0, 1. Okay, so here we write the key. 4/3 means 4.3. Subtopic 6.2 Measures of location. 6.3 Measures of dispersion. Learning outcomes. At the end of this lesson, students should be able to find and interpret the mean, mode, median, quartiles, and percentiles for ungrouped data, to construct and interpret the box and whisker plot for ungrouped data, to find and interpret the variance and standard deviation for ungrouped data, to find and interpret the Pearson coefficients of skewness. Measures in statistics. Measures of location. To determine the central value of a set of data means to determine the mean, median, and mode. For measure of dispersion, to determine the dispersion of a set of the data, it means to find the range, interquartile range, standard deviation, and variance. Measure of location. Mean. The formula is sum of all data divided by number of data. For the data in the form of sequence, we use the formula sum of x divided by n. But if the data in the form of the frequency table, so mean sum of fx divided by sum of f. Mode. The mode of a set of the data is the value that occurs most frequently. Median, quartile, and percentile. Now, we try to divide all of the data into 4 equal parts. 50% of the data, we know this is a median, and also we write as a Q2, second quartile, and 50th percentile. For 25% of the data, this is a first quartile, and also 25th percentile. For 75% of the data, this is a third quartile, and we call as a 75th percentile. To find the interquartile range, we write as a IQR. The formula is subtraction of Q3 and Q1. Semi-interquartile range, symbol as a SIQR. The formula is half of the Q3 minus Q1. To find the any percentile, First, we use the formula n times k over 100 to determine the observation of P. Let's say S belongs to integer. The observation of P is x of S plus with x of x plus 1 over 2. And if S not integer, the observation of Pk is xs, where S is the least integer greater than S. For variance, the formula is sum of x squared minus with 1 over n times sum of x squared over n minus 1. If the data in the form of frequency table, variance is sum of fx squared minus with 1 over n sum of fx squared over n minus 1. Then, to find the standard deviation, symbol as a S is square root of S squared, or this is a square root of variance.
Box and whisker plot. This is another graphical representation of data. It's constructed based on the lowest value, lower quartile Q1, median as a Q2, upper quartile Q3, and the highest value. It can be represented horizontally or vertically. How to draw the box and whisker plot? First, we draw first quartile. This is a first quartile. Next, we draw for median or Q2. Next, we draw for the third quartile, Q3. Then we make a box here. After we plot the minimum value and maximum value, then we draw from the box to the minimum and to the maximum value. Then we find upper boundary. Upper boundary can be determined by using the formula Q3 plus 1.5 Q3 minus Q1. Then we determine the lower boundary by using the formula Q1 minus 1.5 in bracket of Q3 minus Q1. If we have the value bigger than upper boundary, this one we call as a outlier. And then if we have the value lower than lower boundary, this we call as a outlier. The Pearson coefficient of the skewness. We have two formulas to determine the SK. The first is 3 in bracket of mean minus median over standard deviation, and the second is mean minus mode over standard deviation.
Now, how to describe the skewness by using the Pearson's coefficient? If Pearson's coefficient SK is 0, so the data is symmetrical. If SK in between negative 0.1 and 0 and 0 to 0.1, the data is almost symmetrical. If SK less than or equal to negative 0.1, the data is skewed to the left, and if SK is bigger than equal to 1, the data is skewed to the right. Now, we discuss about the skewness by using the measure of location, means using the mean, mode, and median. As we know, median is always the middle value. If mean is equal to mode and median, so the data is symmetrical. If mean is less than mode, mean to the left, so the data is skewed to the left. And if mean is bigger than mode, mean to the right, so the data is skewed to the right. Now, by using the box plot, if the box is same length, the median is in the center of the box, so we call as a symmetrical. If the median, this is a median, nearer to the Q3, so the data is skewed to the left. If the median, this is a median, nearer to the Q1, so the data is skewed to the right.
Example 5. The stem and leaf diagram shows the number of flies caught in an insect trap for 27 days. So we are given a leaf diagram. Okay, and the key is 1, 2 means 12. The first question is we need to find mean, mode, and median. For the mean is actually the total of every data that we have. So we have total of x is equal to starting from 1 plus 1 plus 2 plus and so on plus until the last data 42, 46, 47 plus 47 plus 48. So we gonna total up this value, this data to get 3737. So to find mean, we have to use this formula. Total of x is over with the number of days that we have. So 737 over 27 is gonna be 27.3 as our mean. For the mode, we have to pick the most frequented data, which is in this case is 34. 4 times repeated for 34. So that's gonna be our mode. And lastly, for median, it's actually the half of the data, which is 50% of the data. So we're gonna find for S first, which is in our case is 27, the total number of days, times with 50 over 100. So the observation of the data for 50% is 13.5. Observation of 13.5 is not belong to integer, so we have to choose the least number bigger than s, which is 14. So the median for this data is at the 40th observation, which is 28. For Q1, Q3 and semi-inquartile range, Q1 is also presented by the 25% of the data. So we're going to look for the observation 27 times with 25 over 100. Then we'll get 6.75. And 6.75 is not belong to integer, so we're going to choose the least number bigger than 6.75, which is 7. So our Q1 is equal to, as 7 is equal to 15. That is our 7 data from the observation. Okay, for Q3 is represented by the 75% of the data. So S is equal to 75 times with 25 over 100. And we'll get the observation, which is 20.25. And because 20.25 is not an integer, so we choose the least number bigger than 20.25, which is 21. It means that our third quartile is represented by the 21st observation. 21st observation, which is 37. So for semi-interquartile range, we have to use this formula 1 over 2 Q3 minus Q1. So we'll get 1 over 2 37 minus with 15 to get the answer. So the answer is 11. The next one is we are looking for 81st percentile. So the same thing that we do to find the observation, 27 times with 81 over 100, and we'll get 21.87. So our observation is 22. It means that our P81 is going to be the 22nd data, which is 39.
Variance and standard deviation. First, we determine the sum of x squared. By looking at the data, sum of x squared is 1 square plus 1 square plus 2 square plus 12 square plus until 48 square. The value is 25425. We already have sum of x is 737. Formula for variance, symbol as a s squared, is equal to sum of x squared minus 1 over n times with sum of x in bracket squared over with n minus 1. Substitute all this value. 25425 minus 1 over 27. Sum of x is 737 squared over with n minus 1 is 26. So variance is equal to 204.136. Standard deviation, symbol as s, is equal to square root of variance. So s is equal to square root of 204.136. So standard deviation is equal to 14.29. Illustrate the above data by constructing a box and whisker plot. Hence, describe the skewness of the distribution. First, we determine the lower fence by using formula Q1 minus 1.5 Q3 minus Q1. So 15 minus 1.5, 37 minus 15 is equal to negative 18. For upper fence, the formula is Q3 plus 1.5 Q3 minus Q1. So the value is 37 minus 1.5, 37 minus 15 is equal to 70. From the above data, minimum value is 1, maximum value is 48. First, we draw the suitable scale. And then, by using the information above, we draw Q1 as a 15, Q2 as a median, median is 28, Q3 is 37. Then we draw a box here. Next, we have minimum value is 1, maximum value is 48. We draw from the box to the minimum value and to the maximum value. Lower fence is negative 18. So we draw for lower fence is negative 18 and upper fence is 70. From a box and whisker plot, we see here Q2 is nearer to the Q3, or we can see from longer box and longer whisker is to the left, so the distribution is skewed to the left.